So we have done a couple lessons on factoring to solve quadratic equations, right? So you factor, you take the two factors, you set them equal to 0, and you solve for x. But not all quadratics can be factored. And so we have to have some other ways. And there are a couple of other ways to solve them. And quadratic formula is a lot of people's favorite. It's kind of like that old security blanket, right? It's that favorite one. You've done it before. It feels safe. It feels comfortable. It's a just plug and chug kind of a thing. So we're going to do a little review on solving quadratic equations using quadratic formula. So here's a couple of reminders and steps for you over here. Be sure that your equation is set equal to 0, just like with factoring. We have to set it equal to 0. Be sure that it's in standard form, and then identify A, B, and C. So those three are exactly the same as they were with factoring. So remember, once you have your equation in standard form, that first letter is your A, the second is your B, and the third is your C. And then here's the quadratic formula. Depending on who you had as a teacher, maybe they sung it to you. I love you guys, so I won't sing. If you have Miss Hockman, she actually knows a jazz version of quadratic formula. It's pretty fun. The one that I have heard is to the tune of Pop Goes the Weasel. So here's your quadratic formula. We're going to identify A, B, and C, and then we're just going to pop them in and simplify, which, to be honest, simplifying is where the mistakes happen. So here's our first example. Our quadratic is already set equal to 0. It is already in standard form. A is 2, B is 5, and C is negative 25. I guess I should pull this back down so you can see it. So we're going to substitute 5 in for the B's, and 2 in for the A's, and negative 25 for C. So x equals negative B, which is 5, plus or minus the square root, big long square root of B squared, so 5 squared minus 4 times A times C. And it never fails. My square root's not long enough. The whole thing, all the way from the equal sign, all the way over, all of that is divided by 2 times A, which is 2. Most of the problems occur in here with just signs. If you have a scientific calculator, guys, just enter it exactly like this. Enter 5 squared minus 4 times, like you can enter that as all one thing. If you're using your phone calculator, don't. It's terrible for math. It's fine for like little everyday things, but for actual math problems, your phone is the worst calculator there is. So if you don't have a scientific one handy, open up Google and search for one. So 5 squared is 25. Negative 25 times 2 is negative 50 times negative 4, or you could write minus 4 times. Either way, this is going to become positive 200. All over 2 times 2 is 4. So x equals negative 5. This is 225. The square root of 225 is 15. So plus or minus 15 over 4. So you know how when we factor, we would get the two factors and we would have to set each of them equal to 0 and solve them both separately. So that means we should get usually, often, 2 answers. So this whole plus and minus, those are 2 separate answers, and we have to solve them separately. So we're going to write the first one using the plus and the second one doing minus and do them separately. So the first one is negative 5 plus 15 over 4. Negative 5 plus 15 is 10. 10 divided by 4, if we reduce it, is 5 halves. And then we're going to do the second one with the minus. So this one will be negative 5 minus 15 over 4. Negative 5 minus 15 is negative 20, divided by 4 is negative 5. So our second one is not set equal to 0. So we need to adjust it first by moving the 3x to the left and the 8 to the left. So we get 4x squared plus 6x, and then that'll be negative, so minus 28. A is 4, B is 6, C is negative 28. So I'm going to plug those into quadratic formula. X equals negative B plus and minus the square root of B squared minus 4 times A is 4 times C is negative 28. All of that all the way back to the equal sign over 2 times A. All of this inside the radical is 484. Square root of 484 is 22. So I get negative 6 plus and minus 22 over 8. So we need to do our two separate equations. The first one is negative 6 plus 22 divided by 8. So negative 6 plus 22 is 16 divided by 8 is 2. The second one is negative 6 minus 22 over 8. So negative 28 over 8, it's not a whole number, so I'm just going to reduce the fraction and get negative 7 halves. It would be a great spot, once again, to pause, try your hand at it, and see how you do. So A, it's in standard form, it's set equal to 0. A is 3, B is negative 8, and C is positive 1. So when I plug it in, I get x equals negative B, so negative negative 8, plus and minus the square root of, when you do B squared right here, put it in parentheses. If you don't use parentheses and you're not careful, it will tell you it's negative 64, but negative 8 times negative 8 will always be positive. So use your parentheses if you're going to use your calculator. Minus 4 times 3 times 1, all the way back, starting at the equal sign, that whole thing, everything, all over 2a. So 2 times 3. So negative 8, the opposite of negative 8 is positive 8, plus and minus, this whole square root equals 52 over 6. So when we try to take the square root of 52, it's going to be 7 point something, right? Square root of 49 is 7. Doesn't come out to be a whole number. So this is why we did that lesson earlier this week with simplifying radicals, because we can't leave it like this. We're not going to use a decimal. No decimals. So we have to simplify this radical. So I'm going to come over in the corner over here and do my birthday cake. 52 divided by 2 is 26. 26 divided by 2 is 13. And 13 is only divisible by 13. And there's my candle. So I have a pair of 2's. That means that I can bring a 2 out. $13 does not have a pair, so it's going to stay inside the square root over 6. And then we have one last step. We can simplify or reduce it as a fraction if I can reduce all of the numbers, not the radical, But if I can reduce each of these numbers or divide each of those numbers by the same thing, every one of them, then I can reduce them. 13 is a radical. It's not a whole number. I can't reduce it like I can the other ones. But 8 and 2 and 6 are all divisible by 2. So I can divide each of those by 2 and get 4 plus or minus 1 radical 13 over 3. So we have a couple more. 2 more. Okay. A is 3, B is 14, and C is 3. So go ahead, substitute it all into quadratic formula and start simplifying and see how you do. Oops, I just wrote an A. All over 2A, but A is 3. So remember, I'm just plugging A in for all of the A's in that equation at the top that I gave you, B in for all the B's, and C in for the one C. So I get negative 14 plus and minus 2 answers. All of this inside the radical is 160. All over 2 times 3 is 6. So once again, square root of 160 does not come out to be a whole number. So I need to go over here and do a birthday cake. 160 is divisible by 2, and I get 80. 80 is divisible by 2, and that gives us 40. 40 is divisible by 2. 20 is divisible by 2. And 10 is divisible by 2. And then finally, we get 5 up there. So if I go through and circle all of my pairs, here's a pair of 2's. Here's a pair of 2's. So I can take out a 2 for that one and a 2 for that one. And then the 2 and the 5 don't have pairs. That means they can't come out of the radical. So they have to stay, the 2 and the 5 stay inside the radical. So the 2 times 2 in the front is 4. And the 2 times 5 inside is 10. Okay, so this square root of 160 simplified to 4 root 10. Okay, and then our last thing, just like before, if all 3 integers can be divided by the same number, you can reduce them. 4 and 14 and 6 are all divisible by 2. So to reduce, I'm going to divide them all by 2. Get negative 7 plus and minus 2 square root 10. The 10's in a radical. It's not an integer. It can't get simplified with the rest of them. All over 3. So you could simplify it, or you could not simplify. Sorry, it is simplified. You could separate it into 2 separate ones. So you could write negative 7 plus 2 root 10 over 3. And then your second answer, negative 7 minus 2 root 10 over 3. But since they're not going to simplify, I'm not going to get like 2 separate nice answers. They're both going to be big and ugly. I'm just leaving it like that. I'm not going to separate them because nothing better is going to happen. Okay, here's our last one. It's not in order, so I need to adjust it. X squared minus 9x plus 27 equals 0. A is 1, B is negative 9, and C is 27. So I get x equals negative b, which is negative 9, plus and minus the square root of negative 9 squared minus 4 times a is 1 and c is 27. So again, when you have a negative, put the parentheses around it. All over 2 times 1. Opposite of negative 9, or a negative and a negative, make that positive. Plus and minus the square root of, that will become positive 81, but this is going to still be negative, so I'm going to end up with a negative in here, and it's negative 27 all over 2. So remember, when we have that negative inside a square root from this week's earlier lesson, that negative inside a square root, I'm going to write it as an I in front of the radical. So that negative that's inside the radical becomes an I, an imaginary number, just so that I can simplify the rest of it. 27 now, I can come over here and I'm going to be able to simplify 27. It's divisible by 3, which gives us 9. 9 is divisible by 3, which equals 3. 3 is divisible by 3, and there's our 1 on top. So here we have a pair of 3's that can come outside the radical because it has a pair, and then 1 3 that's left over inside. Okay, so I have 9 plus minus 3 root 3. Remember that I stays right in front of the radical, so it's actually going to be in here in between these two. So I write 3I root 3 all over 2. And then if I look at my 3 integers, they are not all divisible by anything. 9 and 3 and 2 have no common factors, so I can't reduce them. That is my final answer.